Today we're going to show you the integral parts of a lathe that are important, that everybody needs to know before you start using one. This is going to be your switch for threading or just regular turning, your reverser, speed. You adjust the speed by the steps on this belt. They correlate with the pulleys down here to adjust your speed. This is your gauges for threading. Tells you how many threads per inch and the speed that you need to have your lathe turning. This is a chuck. This is a standard 3-jaw chuck. The 3-jaw chuck is good because it moves all the jaws together at one time, as opposed to a 4-jaw chuck. Every one of these jaws moves independently, and trying to get your run out is difficult. It takes an experienced machinist to use one of these, but it allows you to turn oblong objects. And like I say, it takes an experienced person to use one of those. But for now, we're just going to use the standard 3-jaw chuck. Your tool holder, it's got various tools in it. This is a knurling tool, which puts kind of a grip on round objects. This is your standard turning and facing tool. And around the back side that you can't see, we have a kind of a bit that looks like that, that's used for threading. Here we have your tailstock. There are different tools that can be inserted into the tailstock. This particular tool is called a centering drill. You'll punch this in, make your pilot, and this doesn't spin, it's just the chuck spins. And you'll kind of screw this out a little bit, snap that in there, and you'll adjust this wherever you need it to hold your stock, drill your pilot hole, and then what you're going to want to do is remove it. Grab your bearing here, insert it in here, and you'll have a piece of stock between here, and this just kind of helps center it. The last thing you want to do when you're machining any kind of steel is to have any kind of run out whatsoever, and this just holds it between centers. It's called turning between centers when you're turning it like this. The way we're going to be turning here is just a standard turn, not between centers. So we'll get this out of the way. And now we'll start to set up. Any kind of experience with this anymore. This I just made really quick to show you the kind of things that you can do with a lathe. You can make tapers. You can make any kind of design you want to in it. You can thread, and this allows you to make your own custom-made bolts as well as bushings and other things. Okay, the first thing, the tools that you're going to need besides your lathe to be able to use one, it's kind of handy to have a dial caliper, a brush, turning and facing tools of your choice, left hand or right hand, and good quality thread cutting oil. So we've got our work put into our chuck already. We're going to take our run out dial gauge. We're going to put it on our carriage. We're going to get it set as far out as we can get it. And it's probably not going to be perfect the first time you do it, so we're just going to give it a spin here and see what kind of run out we've got. You can look at the gauge and see that we've got about 5 thousandths worth of run out. For what we're going to be doing, that's fine, but any kind of precision machining, you kind of want it to be between 1 and 2 thousandths max. Very rarely you're ever going to get it completely zeroed out, but this will suit our needs just fine. The piece of steel that we're turning now is just over, it's between 15/16 and 1 inch in diameter. If you can see here, it's just a scrap piece of steel that we had laying around. It's nothing special. But the assignment was to take a piece of steel that was greater than 15/16 and turn it to 15/16. So that's what we're going to do. We take our preliminary measurement by putting the dial, making first sure that the dial caliper is set at 0. And this one's just a hair out, so we'll center it up. Open it, put it over the stock, remove it and take a reading, and we're at 962, which is right at, I guess, well, it's just under an inch. I can't think of it off the top of my head, but 15/16 is going to be right at about 9375, which is going to be about right in here. So we're going to take this piece of steel and we're going to turn the diameter down to 15/16 of an inch. The first thing that we need to do, we know our speed's right, we don't need our carriage because we're not threading it. So we know that our stock is running true because we checked it with a gauge. We're going to zero everything out. Zero our cross feed. Okay, we're all zeroed out, we're ready to start turning. So you're going to start by turning your lathe on. We've done some preliminary math. We know how far we're going to have to turn it. You remember that any number that you get diameter-wise that you have to turn down, if you're turning a circle, it's always going to be divided by 2. So in this case, we're going to be cutting it down by 25 thousandths total. So we're only going to turn 12.5. So we've zeroed our lathe out. We're going to go ahead and take 5 thousandths out of this, which is just less than half. And we're going to go ahead and start turning. You make the first pass, back your cross feed off, roll the carriage back, reset your cross feed back to 0, tighten up your So we're in the middle of our second pass now, removing another 5 thousandths. We've already taken off 5, we need 12, so we're just slowly creeping our way through this. Once we finish this second pass, we're going to take a measurement just to be sure we know exactly how much we need to take off. We backed our cross feed off, we're resetting it back to 0, so it'll be ready when we come back. I'm going to grab this dial caliper over here. We know what our final measurement needs to be, which is 9375. And right now we're sitting at 9379. So we're right on. We need to take 2 thousandths out, which is almost immeasurable. Cross feed. You almost won't even notice you're taking anything off. We're only removing about 2 thousandths of an inch. We turn it down to our final diameter. We're going to remove the stock from the chuck. We're going to bring it over to our workbench over here. We're going to take a final measurement. We needed it to be 9375 on our caliper. If you can look there, you can't see it.
It's trying to.
Well, just trust us, we're at 9375. So that takes care of that. And